Hey everyone, in today's video we're going to fully restore this Pioneer SX535 receiver. Longtime fans of this channel may remember I traded 2 beers for 2 Pioneer SX535s with my buddy Tyler, who has his own YouTube channel. Tyler is actually the person that really pushed me off the edge and made me start a YouTube channel of my own, so you all owe it to him for these videos existing. So check out his channel. It's called Diesel with a J before the L in Diesel. So you can call it Diesel JL if you want, but that makes him kind of mad. His channel is all things Jeep, all things Diesel. If you're into that stuff at all, definitely check out his channel and subscribe if you want. But anyways, the conditions of the trade were, if I give him 2 beers, and he gives me 2 receivers, he gets 1 receiver back, restored, and I get to keep this one after I restore it. It's actually been about 1 year, almost to the day, since I traded the beers for these receivers. So this has been getting put off for quite a while, and today I'm finally going to knock it out. I'm going to go through a detailed restoration of everything on here and show you all what it takes to restore a Pioneer receiver. So I'll start the video with kind of a PowerPoint presentation similar to what I did with my Rant video, and I'll talk about how you go about restoring this if you're considering doing it yourself. I'll talk about parts, I'll talk about the service manual, I'll talk about how it works, and then I'll show myself actually restoring this stuff. So I'm going to cut to the PowerPoint right now, and then we'll come right back here when I'm ready to actually show you the work. Welcome everyone to the boring part of this presentation where I go through a PowerPoint presentation kind of explaining what it takes to restore a Pioneer receiver, what things you might want to know, parts that you would want to buy, all kinds of good stuff here. So let's get to it. So this video applies to any Pioneer receiver that's from like the X3X generation, X50 and X80 for the most part. You know, preamplifiers, tuners, power amps, other similar gear, anything from the 70s, and some of this information could be applied to other stereo brands, kind of like Marantz or even Sansui, Kenwood, you know, all kinds of good stuff. You know, they all use very similar off-the-shelf components, so they're all similar in that way. So let's talk about why we're making this video. Why would you want to restore a Pioneer receiver? The number one reason is they're old. You know, in this decade, each one of them is going to turn 50 years old if it's made in the 70s, so electrolytic capacitors fail with time and usage, and transistors can fail as well. It's probably got dirty controls, and it's probably got burnt out lamps and stuff, so, you know, restoring a receiver can be a pretty good thing. But why would you do it? What are the benefits? The number one benefit of restoring a receiver is reliability. Like I just said, there's old components in here that have a tendency to fail or can fail, and when you replace every single one of them, you've just made your receiver very reliable. It may perform better, you know, it might run cooler because while you're in there you can make adjustments, you can make sure everything is set correctly, and it might sound better if your receiver's in kind of bad shape, but it's probably not going to sound any different really. You know, I recently restored a Marantz 2215B and I took before and after audio recordings of that receiver. I really can't tell a difference in the sound of that receiver. Obviously there's drawbacks to this. It takes a lot of time, it's very tedious, and if you've never done this before, you could likely mess something up and you might not know how to go about correcting it. So if you're going to do this, it might be good to have a practice unit. If you're trying to get into this stuff, you know, practice on something first. If you've never soldered, you're going to need to know how to do that. So that kind of relates to this slide here. I want to restore my Pioneer receiver. Now what? So the main things you really need to understand are, 1, Ohm's law. You got to understand the dangers of working with electronics because it's kind of dangerous if you don't know what you're doing, and you can electrocute yourself. So if this scares you, stop right now. I'm not responsible if you hurt yourself. Understand how the receiver works, which I'll kind of get to in a minute here. Understand how to use the service manual and read a schematic, which I will also get to in this video. But most importantly, you need to know how to solder. You can look at YouTube videos, unless I can show a brief demonstration later in this video, but, you know, look into this. Make sure you know how to solder. Make sure you've got the right tools for the job. I've got a great video on this. I'll link it in the corner here, right? Yeah, something like that. And there's probably other stuff I'm forgetting. There's just a lot you need to know to successfully do this. So let's say you've just completed that checklist. You understand everything. So when you're going to restore a receiver, what you should do is clean the controls, repair any issues that exist initially, because if you have an issue that exists initially, you need to know what that issue is and you need to fix it and repair it before you start restoring it, because especially if you've never done this before, once you go to restore a receiver, you're replacing a lot of parts and you may not know how to come out of that if you make a mistake. But yeah, then spend money on the parts, install them, and enjoy your restored receiver. So, I'm going to walk through a very rough explanation of how this receiver works. It's going to be very rough. Some people might find it misleading, but you know, it's not completely untrue. It's just kind of good to know how this thing works. Alright, let's walk through this. This is going to be nice and crude. So, over here what we have is our wall outlet, and this is 120 volts AC. So where's this going? It's going through your power switch. There's a little bit of other stuff here, but we're just going to keep this nice and crude. Next place this thing goes is your transformer. This is the symbol for transformers. Now what the transformer is doing, it's taking this 120 volts AC and it's stepping it down to a smaller voltage that the Pioneer wants. On our Pioneer SX535, just put that up there, it's going to do this in 3 different voltages. The first one is going to be for your lamps. It's going to be 8 volts, and what this is going to do is it's going to go to your lamps right here, and that's going to go off to ground. So that's one of the legs. The next one is going to be for your receiver power supply, basically. This right here is going to give like a certain voltage to basically all the boards on the receiver that require some amount of power to work. And then down here we've got a set of secondaries, is what you call it. So here's your primary, this is your secondary, all 3 of these. It's got a set of secondaries that are going to go to a bridge rectifier. Let's make this a little wider. A bridge rectifier looks a little something like this. Now, this is way crude. I might not have these diode directions right, but if you see something that looks kind of like this on your schematic, this is what's called a bridge rectifier. And what this bridge rectifier is about to do is it's about to create DC voltages for your power amplifier. So right here we're going to keep moving along, and where this is going to go is to filter capacitors. Now again, remember, this is extremely crude. These filter capacitors, what they're going to do is they're going to create a positive rail voltage and a negative rail voltage for your power amplifier. So these guys right here, these are the big fat cans that are attached to the chassis of the receiver, and they work for the power amplifier. Now that we understand how the power kind of comes out of the transformer and goes to like 3 main things, let's talk about the second thing that we're concerned with here, which is signal. So over here we've got our inputs. We have aux input, we have tape input, we have phono input, and then technically we also have tuner input. Where are these all going? Well, aux and tape are going to go straight to what you call the selector switch, and your selector switch is going to switch between all of these, and the tuner is going to go here as well. But what's going to happen with the phono input? The phono first goes through the phono preamplifier. The phono preamp takes the little tiny signals from that little tiny stylus on your record player and makes them so that they're comparable to the aux and tape and tuner signals. So that's why you need a phono preamp. If you plug an iPod into the phono preamp, it's going to be extremely loud and extremely distorted because it's getting amplified by this thing unnecessarily. It doesn't need to go through here. Only the phono signal has to go through the phono preamp. So now that we have everything going through the selector switch, next place we go is the preamplifier. Now, you might go through the volume knob before you go to the preamplifier, but I'm just going to draw this as if the volume pot is after, or volume control. So what this has is, it has your bass, it has your mid control, it's got the loudness control. This has all the stuff that controls like how you want the signal to sound, and it conditions it for the power amplifier. So after we go through the volume control, we're going into our power amplifier. So think of the power amplifier as like a tree chipper. It's going to take whatever it gets and it's going to make it a certain amount louder, like convert it a certain way, you know? The volume control is associated with the preamplifier. I think it's a common misconception. The volume control has honestly nothing to do with the power amplifier. It's got everything to do with the preamplifier. Now after it goes through the power amplifier, it's going to make the signal loud. I've been using 1 line here because, you know, this is super basic, but now we're just going to make it 2 lines because we're dealing with stereo receivers. So next place we're going to go is the speakers, actually, because the Pioneer SX535 does not have a protection relay. But if we did have a protection relay, let's just make this a dotted line here, because it doesn't actually exist in the 535. This is where your relay is going to live. You've got your right signal and your left signal going into there. Then, where we're going to go is the speaker switches. These are your A speaker, B speaker switches. This is where they are working. They're like the last stop before it goes through here. And then after it goes through the speaker switches, you go right out to your speakers. So this power supply, let's make this all nice and confusing here. What this thing's going to do is it's going to send a certain voltage to, for example, the Phono preamp. It's going to go to the tuner, it's going to go to the preamplifier, it's going to go to the power amplifier, and if applicable, it's going to go to the protection circuit. So hopefully I didn't lose you there, but in a very basic nutshell, this is kind of how the receiver works. Just it's important to understand, like, you know, if you're having issues that can be controlled with the volume knob, you've probably got an issue right here in your preamplifier, because this is where it all starts on your inputs. It's going to go through your selector switch, it's going to go into the preamplifier, the volume control, then it's going to go here. But if you've got an issue that's audible at any volume, no matter what, probably got something to do with the power amplifier. And if you're not getting any sound at all, well, maybe your protection circuit is kicked in if you have one, or maybe your speaker switches are dirty, maybe your volume control is dirty. It's just good to understand, you know, where all this stuff comes from when you're going to go about repairing or restoring. That's my very basic outline. Hopefully that made some sense to you and gave you some enlightenment. But please, you know, do more research to figure out how this really works, because this is super basic. Okay, now that we know how the Pioneer receiver works, let's take a look at the service manual. We're going to look at the service manual for the Pioneer SX535 because that is our subject of this video. The service manual always starts with, you know, a cover page, and you got your specifications right here. Sometimes this is at the back of a service manual, but on this one it's on the second page. You know, all kinds of good stuff here. Then here's a block level diagram of how the receiver works. This is probably a better thing for me to use when describing how the receiver works, but it's still a little bit complicated, as you can see. You know, my thing was much simpler than this. This is not misleading at all because, you know, it comes from Pioneer, so if you want a better explanation of that, you can take a look at that. That's just fine. This is a picture of, you know, where everything is physically on the receiver, which is great if you're trying to find something and you don't know what to look for. This is an important section here. It tells you how to adjust, you know, the tuner if you're about to do an FM alignment. I'm not going to talk about that in this video because I don't know how to do an FM alignment, but I'm going to learn how to soon. This is more FM alignment stuff, and then here's AM alignment, probably similar to FM but simpler. This is a section you're definitely going to be concerned with, though. We're looking at the power amplifier adjustments. So the Pioneer SX535 happens to be a very simple kind of lower level receiver. So the only adjustment you're going to see here is adjustment for amplifier bias. Normally you'd find a DC offset adjustment here and tell you which potentiometer to turn to set your DC offset. But the Pioneer SX535 is so basic that it doesn't even have that. So most receivers are going to have that. You're going to want to follow that if your receiver has it. Some Pioneers might have a power supply adjustment section too. It's going to be very similar to, you know, setting your bias. You know, you put your multimeter terminals on a thing and adjust the potentiometer for a desired voltage. If you need to restring your dial, this is how you would do it. It tells you how right here. I've never had to do this on a Pioneer. I've had to do it on quite a few Marantzes. I think Pioneer used a little bit higher quality string than Marantz did, but just in case you need it. And if you're lucky enough to have your original box, well, here's how it goes together. So now we're about to get into the nitty-gritty here, what we're actually going to be using for the restoration process. So here's an exploded view.
if you're looking for a specific part. You know, this is kind of helpful. I don't ever use that really. But here's the meat and potatoes right here, the schematic diagram. This tells you exactly how the receiver works. You see on this particular service manual it's split into 2 pages. So if you want to print this out, you're going to get a better picture of all of this. If you're restoring and you're not terribly familiar with schematics, you're going to want to learn the best you can how these schematics work. But if you're just replacing parts, that full schematic's not going to be too helpful to you. What's going to be helpful to you is this stuff right here. So what we've got here is a list of kind of like parts that are on the chassis right here. You know, we see it's like transformer, fuses, antennas. This is all stuff that is not on a circuit board. But if we keep going down here, suddenly we start seeing board level schematics. So this right here is your schematic for the tuner board. And here's a foil view of that tuner board. So if you're looking to replace all of the electrolytic capacitors on your tuner board, this is where you're going to go to find their values. So this is how they do it. They start listing the capacitors on a board and they give them a designator called like C1, C2, just like this. You're going to go through and you're going to find ones that say electrolytic. When it says electrolytic, that's when you're going to be concerned with replacing, and then you go see that it's a 4.7 microfarad 25 volt capacitor. That's what you're going to use to find a replacement. Ceramic capacitors, you're going to want to leave those alone. But here's the most painful part about a Pioneer service manual, at least this one here. Let's talk about C44 for instance. You can look at this board on your receiver and it's not going to say C44 anywhere. Other receiver manufacturers, they would actually have the circuit board say C44 right there on the board, so that's how you can identify it. The only way to find out where C44 is on this receiver is if you go right here, you zoom in on this view, and you go look for C44. So I see right here that there's C42, and this is a particularly bad example. This is not a good quality scan of this service manual. So it's going to be very difficult to find the capacitor on here. So that's kind of my issue with Pioneer service manuals. I really don't like that about them. However, you don't have to be finding these components right there on the board. You can just look at the board, identify that as an electrolytic capacitor, read the actual value on that capacitor, and then you can go about finding your replacement. And that's honestly probably the best thing to do, because here's something that is kind of important to know about service manuals. They almost always have an error in them. These service manuals are published at a certain time, but the engineers at Pioneer might have found that, hey, if we change this component, it makes the receiver perform better. I'm going to put out a notice to the production floor and have them load this capacitor with a 3.3 microfarad instead of a 4.7, for example. That change is not going to make it to the service manual. So when you go to your service manual, take every single thing you read with a grain of salt and confirm that what's in the manual is what's on the board. If your receiver is original, it's not been tampered with, and you find something on the board that is different than what you find in the service manual, the board is likely the correct component, because that's the final line. The production floor is the last stop for this thing meeting the specifications that the engineers wanted. So just be aware of that. Now here's another board right here. We've got the equalizer amplifier assembly. This is your Phono preamp. And we talk a little bit more about this board in detail later. So here's that foil view. We want C6, we want C5. To replace those, this is how you would identify them. It's not going to say C6 and C5 on the board. You're going to have to look right here. One cool little note about these circuit boards. So this is the symbol for capacitor, right? These little bars right here. If we look right here at C10, we see that there is nothing in between these two bars, kind of like there is with C12 over here. Those little lines between these bars means that it is an electrolytic capacitor. You also know that it's an electrolytic because it's got a little plus sign right here. See this one right here? If we go to C10 in the components list, it's going to say it's a ceramic. And I know that because there's no positive designator and there's nothing in between these bars. So let's just check that out right now. Look, C10, ceramic. Right there. C12, electrolytic. So that's kind of fun. Yeah, like I said, you know, these components are named C for capacitor, and then R for resistor, Q for semiconductor, and then there's other stuff, just not on this board. So here we've got our switch control assembly, which actually happens to house our preamplifier on this receiver. We've got capacitors, foil view, resistors, and then VR, that's variable resistor, and then S is switch. Here's our power amplifier. Foil view, components list. Here's another thing that's kind of annoying about a Pioneer receiver, is that every board has its own set of, you know, R1, R2. There's multiple R1s in this receiver, whereas the way Marantz did it, they named their board like P800, for example. So the first example in that board is going to be R801, and there's only one R801 in the entire receiver, whereas with this thing, there's going to be multiple R1s. So it's like if I'm talking to somebody who's familiar with the unit I'm working on, I can just say, oh yeah, H701, and they know immediately that that is the first transistor in the power amplifier board, or the Phono preamp board, depending on what Marantz, you know, but, you know, I'm getting on a little bit of a tangent here. So anyways, and then D is diode, L is inductor, F is going to be a fuse. This is the symbol for fuse. This is diode. You know, all kinds of fun stuff here. This is our power supply board. So we've reached the end of the service manual here, and these are really what you're going to be using for finding components, making sure you've got the right ones. These service manuals are absolutely necessary if you're going to be making repairs, because once you understand how the receiver works, you can see then, oh, it's behaving this way, and based on how the receiver works, that means the issue has to be in this part of the receiver. So I'm going to go look here, and I'm going to look at the schematic and see, okay, which component is causing it to misbehave, and just kind of go from there, start checking voltages. And that's another really cool thing about the service manuals. It's not showing it here, but if I go back to the top level schematic diagram at the very top here, and I want to look at the power supply board. So where's the power supply board? It's right here. Power supply assembly. So this dotted line right here represents the board and what is actually on it. And then these lines represent wires going to other locations in the receiver. This view generally has things like this. Look at this negative 41 volts right here. Look at this 13 volts right here. If your receiver is behaving in a strange way that you think is related to the power supply, go to this view, look at these voltages, check and see if these voltages exist on your power supply board. If you think a transistor is misbehaving, you know, in a perfect world this is a better quality scan, but you know, I can see this says about 30 point something volts. If I don't see these voltages at my transistors, well then I know something's probably wrong with one of my transistors, or something is causing the transistor not to work right. So I know that was a little disorganized and kind of tangent-y, but that's in a nutshell how the service manual works, and you can use this to your advantage when you're restoring this stuff and repairing it. So let's move on. Hopefully now that you have a basic understanding of how the receiver works, you can use this combined with your knowledge of electronics and soldering to fix your receiver before you restore it. It's much easier to just shotgun replace parts. It's not good practice though. It's very difficult to actually repair something because it requires you to understand how it works. So I encourage all of you to try to get to that point before you attempt a restoration. So let's say you're there. We need to buy parts, and we're going to talk about all of these parts here, so as they pertain to Pioneers. Electrolytic capacitors, transistors, diodes, lamps, thermal compound, power switches, and relays, if applicable. So let's go through here. There's multiple kinds of capacitors in the electrolytic world, and we're concerned with replacing electrolytic capacitors and tantalum capacitors on these receivers. There's multiple kinds of circuits in these receivers and amplifiers. So for a circuit that concerns your signal path, you're going to want to use an audio grade capacitor like a Nichicon KA, KW, FG, L-Nasilmic 2, a film capacitor, something like that. For a circuit that pertains to power, you're going to want to use a low impedance capacitor like a Nichicon PW series. If the capacitance of a capacitor is kind of low, you could use a WIMA MKS series film capacitor, which has no polarity. We'll get into that in a minute. I've got a video describing this stuff in further detail, so I'll link that up here once again. But here's the burning question. How do I know if a capacitor is in the signal path or the power circuit? Let's take this board here as our example. This is the Phono preamplifier board for the Pioneer SX535. We see that I've identified 4 audio grade capacitors here on this board. So how did I do that? If we look at the full schematic diagram in the service manual, we see that pin 2 and pin 8 are where the signal from your record player enter the Phono preamplifier. So let's go to pin 2. Let's watch that. Let's look at that path here. And this board is symmetrical because this is a stereo receiver, so it has a right and a left channel. So there's 2 of the same circuit for each side of the board. That's why it looks this way. We're going to go with pin 2 for example. Pin 8 is basically the same thing. If we follow this signal, we see it goes through resistor, R1, and then it goes through a capacitor, C1. It's a 3.3 microfarad 10 volt capacitor. And then it goes right into a transistor. Notice where it's not going to ground. So we know that the signal path does not go to ground because it would just disappear. It's going through other things. This is where the signal path is going through. It's going right through this capacitor. So we know that C1 is an audio grade capacitor. If we keep looking here, we know that pin 4 and pin 6 are the signal outputs if you look at the schematic. So if we look at pin 4 and go back a little bit, C13, that is the last stop for our signal. It's going right through that. So we know that needs to be an audio grade capacitor as well. So C1, 2, 13, and 14, those are the audio grades. So now let's look at the rest of them. Let's look at C3 for example. We know that it's related to power because take a look. That negative leg of the C3, it goes to that thick black line, that's ground. Same thing with C5. We look at that negative leg, it's going right to ground. And then the last 2, C11 up here and C12 down here, those also go to ground. So we know the signal path is not going to ground. We know that the signal path's not going to go through those because they're going straight to ground. So they're related to power. So you don't need an audio grade capacitor right there. You can use a Nichicon PW. This is a pretty simple circuit. It was pretty easy to identify how this all works. It can get a little more complicated with more complicated circuits on like the higher end receivers, but this is just a basic lesson in how you can go about identifying this stuff. We have filter capacitors too. They are electrolytic. In all honesty, I haven't really seen a filter capacitor that's tested bad per se. They always have the capacitance they're rated to, but like everything else, they're old and they can fail, so I like to go ahead and just replace these with brand new ones. I've got a video explaining how to replace filter capacitors, and I also go through it on this video too, so stay tuned for that. I'll probably put a link in the timestamps in the description or something. So let's talk about transistors. This is where things get controversial. I think it is a great idea to replace all transistors in the power supply, the protection circuit, the preamplifier, and the phono preamplifier. It gets a little iffy in the power amplifier because certain transistors they use in there are for very specific applications, but on Pioneers especially, the differential pair transistors should be replaced, and sometimes the bias transistor should be replaced as well. Diodes. It's optional to replace diodes. And this is controversial also. You know, I've received some feedback saying, like, you know, in my Marantz restore video, I said you should replace diodes. And people came back and said, no, you don't actually have to replace diodes. But what's funny is the amount of anger they came at me with that suggestion over the replacement of a part that costs 10 cents. You know, that's funny to me, you know. You can replace them if you want. Modern semiconductors are better than old semiconductors, and if you think you're going to get that extra bit of performance out of your receiver by replacing the diodes, you're welcome to do that. I've seen diodes fail. I've seen plenty of Zener diodes fail, and in this video, I don't replace the power supply diodes just because I simply didn't really feel like it, but it's an option you could consider when you're restoring your receiver. Do your research, see if you agree with the people that believe that replacing power supply diodes gives you a better sound stage or reduces noise at no volume. There's lots of different opinions out there. Just come to your own conclusions. If you want to just replace the electrolytics and call it good, that's fine. I really don't care what you do, but this is just my experience. I've got a great video on this here. When looking for transistor and diode replacements, oftentimes it works to search the original part number followed by replacement. Look for a forum thread where somebody confirmed a good replacement for that original part number. Be cautious though, especially with transistors, for it might not be a good replacement for your application. I'll link that video up here. I've come across this and I've had to go back to original transistors because of bad substitution suggestions. On the tuner boards, this is kind of where my knowledge has a bit of a gap. I don't know exactly how tuner boards work, and most kits just say you should replace them with like a PW series capacitor and leave the semiconductors alone. So that's how I handle tuner boards. I just recap them and leave them be. Lamps. The X3X receivers use fuse lamps. I'm pretty sure the X2X receivers use them too, but I'm not exactly sure. But the X50 and X80 receivers use 3 or 4 lamps that mount to a plastic piece that kind of diffuses the light evenly across the silver display. These are extremely easy to replace if you have to replace your lamps or if you want to upgrade to LED. However, on Pioneers, indicator lamp replacement can be kind of tedious because they're glued into holes and you have to kind of pull them out by the wires, solder new wires to different boards, or make splices with wires. It's not like a Marantz indicator lamp where it's actually on a circuit board and you just desolder the bi pin from the circuit board. Indicator lamp replacement can be kind of difficult on these, but if it's burnt out and you want it working again, that's just kind of what you got to do. Thermal compound. This applies to your output transistors on your power amplifier heat sinks and any power supply transistors that are on little tiny heat sinks too. Certain transistors in here get very hot, especially on the power supply, so if they use thermal compound, that compound degrades over time, so it helps to put some new stuff on there to get better heat transfer and extend the life and reduce load on these transistors. I show how to do this in the coming video footage here. Power switches on Pioneer receivers are actually pretty okay. I haven't seen one fail. I have seen the switches fail that, on, for example, the SX750 has a power switch integrated into the speaker control switch. So if you want to switch from A speakers to B speakers or run them both or turn them off, your power switch is integrated into that. Those can fail sometimes, and I do not know of a good replacement for that. So that's kind of unfortunate. I wish I had more to say about that. Some Pioneer receivers use protection relays. I wish they all did, but they don't. And ones that don't use a protection relay can be very dangerous for your speakers if you're running original differential pairs, original preamplifier transistors, and original bias transistors. I've got videos on this. But if it's got a relay, you're in much better shape. What's kind of cool about Pioneer receivers is I've noticed that they use an MY4 relay, which is different from a Marantz. Marantz used an MY2 relay, which has 2 contacts, 1 for each channel, whereas the MY4, it's got 4 contacts and they use 2 contacts per channel. I think this increases reliability because you don't have 1 contact, you have 2. So if one starts working less than ideally, you've got the other one to back it up, or the load is distributed between the 2. I haven't seen a relay fail on a Pioneer, but I have seen them fail on a Marantz. So if you want to replace it, look for the correct part number. It's an Omron MY4 relay, but just be careful with that. How do we get started with all this knowledge I've just covered? Just pick a board. Start with it. It doesn't really matter where you start on this thing. If you're going to restore it, just pick a board and go with it. And that's what I do in the coming footage. Replace components one at a time. And when you finish, put the board back together, mount it back in the receiver, test it with your dim bulb tester. Make sure it's still working. I haven't talked about the dim bulb tester yet. It's very important you do this stuff with a dim bulb tester. I've got a video on how that works and why it's important, so go check that out. When you're working on the power amplifier board, when it's finished, You're going to want to set the bias and DC offset, and just like it says in the service manual. I showed you where it says all that stuff. And then Pioneer power supplies, they might have a voltage adjustment, but on this one that I'm working on, it does not have a voltage adjustment, so just make sure you don't miss that. So that's it, folks. That is my PowerPoint presentation. So without further ado, let's start watching some video on this stuff actually getting put to use.
Okay, we're back. So this thing has actually been in 2 videos already. I did a relamp job on this receiver. You can check that out there. And then there was another video where I actually repaired this, and you can check that video out there as well. When I got this, it had really bad DC at the speaker terminals, and since this has no protection relay, I had the potential to really do some bad damage to any speaker that could have been connected to this. So that's been taken care of. This thing works now, but everything in here is original except for those transistors I replaced. So it's time for a restoration because electrolytic caps go bad. There's a lot of transistors in this series in particular that are known to go bad and should not be in here any longer. So we're going to get rid of those, replace them with new stuff, and maybe we'll even do a power test at the end of this and hook it up to the scope and we can see how many watts per channel this thing's actually putting out. So without further ado, I'll show you around this thing and we'll pick a board to start on. So like I said, Pioneer SX535, and I've already done a relamp job on this. I'll show you that right now. You can see we've got really nice LEDs in here. You can't really tell in the camera, but in person it's very obvious. It's got a very cool blue glow to it. I kind of like these Pioneers with LEDs, but I don't like the Marantzas with LEDs. I don't know what that's all about. We look inside here. We've got basically original everything. The power supply is all original. Tuner board is all original. But the power amplifier board here, you can see those 2 little limit capacitors I replaced. I just kind of did those when I was in there. Kind of jumped the gun on the restoration a little bit, but you can see there's a few new transistors in there. Like I've said, that other video, you can check that out and see how we fixed it. So that's one point I want to make here. You always want to fix these things before you go and restore them, because that's just good practice. You want to understand how this thing works, and you want to know that it's going to work after you restore it. Only do this if you're very comfortable, okay? Alright. If we look underneath also, let's see. We've got some boards here too, so 2 of them under here in particular. We've got the Phono preamplifier board, or EQ amplifier, and then this right here is your preamplifier, and you know that because you've got your bass and treble knobs attached to it. I think what I'll do is I'll just start on the bottom, because that's how I started with the Rant's video, so that's how I'll start here. Let's start with the preamplifier assembly. Okay, so turn it off, unplug it, and now we're basically safe to work on this thing. So it's pretty straightforward how to get these 2 covers off. I'm not going to talk about that because if you can't figure that out, you have no business attempting what I'm about to show, frankly. Okay, faceplate. Pretty easy to get off on these Pioneers. You've got 2 screws up top here, sometimes 3. And I'll take this moment to mention this. I think I'll mention this in the PowerPoint. I haven't recorded that section yet, but I'll just say here, not all Pioneers are the same. They're all quite different from one another, actually. So if you're looking to restore like a Pioneer SX1080 and you're watching this video is not going to help you very much at all. Because there's been so many changes to these things over the course of, Pioneer making these. Like, Marantz, they stuck with a pretty consistent design through a lot of the 70s and a lot of their models. Pioneer, it's all over the place. I think it was a little bit more expensive to manufacture these just because they didn't have so many common parts like Marantz did. But that's not a bad thing. These are still fine receivers, with some exceptions, I guess. So you just saw me remove these 5 knobs. You just pull them off. Try to keep them in the order in which you removed them. So I'm going to put these back here. They're arranged in the order they came off. I'll come back to them later when I'm ready to reinstall the faceplate. Tuner knob. This is glass, so be careful. It also comes off with just a nice tug. And then we have 2 nuts right here. So what you do there is you you have your deep socket set, you find out which one is it. On this receiver it looks like it's a 12. So I don't think I have my ratchet in here, so let's see if I can get this off by hand. Yes, I can. Unless it choked me. Oh, I can. Yeah, you might need a ratchet, but oftentimes I find these are pretty loose, so it doesn't take too much to get them off. These nuts and washers are the same, so it doesn't really matter if you switch the order, but I try to keep them in the order I took them off anyways. Okay, so there's that. That slides right off. We'll put it somewhere safe so it doesn't get scratched or damaged. Put it between the Jaguar seats. Next thing we need to do is start removing the preamplifier board. The preamplifier assembly is basically this whole thing. You can see that under here too, like this. Okay, you can't quite see it in the angle, but this is a very big, long board. It's going like the entire width of the receiver. So that means these 6 Phillips head screws are going to be key to getting this out. So we want to get this out. I've just loosened all 6 so we can see, you know, the thing's loose. This is what we need to get out. Okay, so as you can see, we're loose now. Now what I will do is flip over. We're going to be very mindful of our tuner pointer because, you know, if this comes off the track and you break it, well, that's no fun. I actually broke this in the video where I did the relamp job, so you can see how easily that can happen. Okay, so this you got to be a little careful. They designed it so you can slide this forward and then bring it out, but just watch your wires. I see a few places where it might be a little tight. It's a little plastic thing that kind of traps the wires and guides them through the receiver. If you pull some of the wires out of there, like I'm doing now, that can help you and give you some extra length. So that's what I needed right there. And we're looking to have these shafts clear the sheet metal in front here. Doesn't look like we're pulling anybody too tight. Just a little bit of spring action from the wires. And there, I just lifted the shafts past this member here. And now what we have is full access to the foil side of this PCB. So that's good stuff. So let's get to work here. I think I'll work on it just like this. This seems like a nice angle to get to things. And yeah, I think it's going to treat me pretty well. I'll get a few more of these wires out of these wire ways, just to give myself that freedom. And there's a few. Okay. Let's see. A lot more freedom there, so we'll just, all you gotta do is put the wires back when you're done. There's not much going on here, there's not too much to do, but now what we can do is we can break out the service manual and we can see what it is that we need. Okay, so I've got the service manual up on my laptop here, and I've put it to the schematic page for this board. You can see the foil view of the board here. One thing that's kind of annoying about Pioneer is that if you look here, you can see like R3, it's right there, VR1, it's right there, Q2. Those names are not on this board. So if you're going to look for something, let's say you're looking at the schematic or this bill of materials, you need to reference this thing, find your component on here, and then locate it on the board. So I don't like that about Pioneers. It's really, it's just tedious to me. But it is what it is, and we get by. So as we can see, we've got some electrolytic capacitors. We have this one, this one, this one, this one, these blue ones, this one that's bent a little bit. Those are all going to get replaced because they're electrolytic capacitors. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. I will pull replacement for each one of those, but the question is, which of these get replaced with an audio grade capacitor and which ones get replaced with a low ESR or low impedance capacitor for power circuits? So the way we do that is we can look at the circuit. So I will just briefly go through this because it's pretty simple. As you can see, it's not a very complicated circuit. Most preamplifiers on most receivers have like at least more than one transistor per channel. This is symmetrical because we've got a right channel and a left channel. So I've found out that the audio comes in right here and it exits up here at 11 and 12. So we can start following the signal. First thing it does is it goes through this 2.2K resistor, and then it goes through this thing. That is a signal path capacitor. We know that because, well, the signal is just going right along through it. So let's keep going here. We see C9, that's 100 microfarad / 6. It's kind of a high capacitance for being an audio grade. So also we notice that it goes straight to a resistor and then to ground. So probably not audio grade. But as we keep moving through here, we can assume that the signal goes like, either that way or that way. But basically we're going to look right here at C11. This is audio grade as well because it's not going directly to ground. And it's a small capacitance, so that's a giveaway. And then as we move up here, that's going right to ground. That's probably a power grade. And this one over here, same with this one. There's only one of them. So what that tells us is that it's probably related to power for the circuit. So that's how you can tell looking at the schematic. But if we go back to the board, we see that those little .47s that were audio grade in the circuit, these little blue ones right here. So those little blue guys on here, almost always an audio grade capacitor. And if it's black, almost always a power grade capacitor. So that's how I'm doing that. And then next, we see we have one transistor in each channel, and that transistor is a 2SC1344. This is going to be replaced with a KSC1845, and that's going to prevent any failures in here, because like sometimes these older Pioneer transistors, they'll get noisy and they can shoot DC to your amplifier, and you don't want that. I've got videos showing that happening. I'm going to take a minute and assemble my bill of materials here, and I'll report back when I've got them. Okay, we've got our new parts right here. I pulled those from my stash. Let's take a look at the bill of material here real quick, the component list. You'll notice that on this list of parts, and even in the schematic if you look closely, there's a capacitor missing from here. It says there's only one of these 330 microfarad capacitors, but there's actually two on this board. So this is something you'll see sometimes. The service manual is not always correct. Oftentimes what will happen is, maybe they'll miss something in here. Maybe the engineers want to make a quick change. They can send out a notice to the production floor, and they can make changes to how the boards are filled, or like what values of components go in. So what you see here is not always going to be right, but it's at least going to be close. So take everything with a grain of salt, check it against what's actually on the board every time. Because if we were buying these one by one on Mauser, well, we'd be kind of disappointed if we only had one of these 330 microfarad caps and we had to leave one there, or spend $8 on shipping for a 25-cent part, Don't need any of that. That's no fun. But yeah, like you see, we've got 9 listed here. There's actually 10. So let's take a look. We've got our film capacitors for those little blue ones that are in the audio path. And we've got our Nichicon PWs over here, and then we've got 2 KSC1845 transistors that I matched. It's time to start soldering. I'm going to start getting to that with my Heiko FR300. You can buy an FR301 these days because this is discontinued. This is what I'll be using to desolder all the things, and then I'll use my trusty old Weller to solder stuff in. Okay, so the way I go about desoldering this stuff is I take my FR301, it's got a little vacuum pump in it. We're going to start over here with the big 330s. So the way you find the leads on the other side of the board is you pay close attention to how they're mounted in here. Like I see that this capacitor, it's going to have its leads going this way because I see the negative lead on a side going this way, if you will. Let me show you what I mean with that. So I'm going to pull this one. So let's just make sure those are free. We've got some glue underneath this one, so what I'm doing is I'm just kind of bending it, waiting for the glue to kind of snap on the other side. You can hear it cracking. And I'm keeping heat on these leads because, there, okay, so the glue's starting to go. Maybe you can see that, I'm not sure, but you can see the leads kind of getting sucked into the board because what I'm doing is I'm just pushing on it like this, and it's going slowly because there is glue. So I'm going to come back in, make sure that my leads are, separated, that I don't push any traces off of the board. And now I'm going to go to the side. Okay, so there it was. Yeah, this one looks disgusting. This is glue from the assembly process, but this stuff is bad. I think it can lead to corrosion of these leads. It doesn't look like this has happened just yet, but it was probably only a matter of time before it started getting pretty bad. So, what I mean by, so you see these leads right here. They're in this orientation, side to side. They're not going up and down like these two right here. So, and I knew that, so what I did was I looked for this line right here to be on either this side or this side. Now, the next 330 cap on here is right here. Can you even see that? So it's right there, you can see it, and you may not be able to see it in the camera, but the negative strip is kind of on this side of it. It's not on the back side or on either side of it, it's on this side coming toward me. So that tells me that the joints are going to be in an up-down arrangement, like this. So now that I see this, I'm going to go desolder those two, and that'll be my second 330. And then I'll keep heat on here. See there, I've already lifted one of the traces off of the board. I'll see if I can zoom in on that. You can see that trace is moving around, and that's bad news. You do not want to see that happening right there. So what you do, you take your soldering iron or FR300, you just kind of leave it there, but keep moving the capacitor around a little bit. And that way, when you remove it, these leads don't want to take the trace with it or push it back out. We've still got enough trace on here to solder something new to, which we're going to have to do quite soon, actually. The other thing you need to do is, after you've removed something, or even before you remove it, confirm that the board was marked correctly. Because these electrolytic capacitors, they've got a polarity. So here's the negative, and the positive is unmarked. And if you look at the board, where our two big caps used to be, you can see the glue marks. There is a plus sign. See one right there? That is a plus sign on the board, and that tells you that your positive lead for your capacitor goes in there. And we confirmed that the negative lead on that capacitor was kind of facing me from where I'm standing over here on, in front of the receiver. So we know that that's right. Now, what that means when we go to load a new part, here's our new part, 330 50 volt, is the long lead on new electrolytics is always the positive one. So you just take the long lead and put it where the positive sign is. One lead, two lead, and just kind of put it in there, right? And then on this side, we're going to bend the lead back, put it in the direction of the foils. That's just good practice in general. What I mean by that is, let's take this top lead for example. We wouldn't want to bend this toward the other lead because then that would increase our chance of creating a short circuit with this lead right here. Not that this is high enough voltage where that's actually going to happen, but it's just good practice to bend your lead in the direction of the foil that this joint circuit is actually on. So like this one we're bending down because we're following this foil. We could also bend along this one right here if we wanted to, but I'd go down just because, I don't know. So while we're loading parts, let's take our other 330, and you'll notice that this used to be a 35 volt. One reason I'm going with a 50 volt
is because, well, I didn't have a 35 volt on hand. And when you up the voltage on a capacitor, that's not a bad thing. If you up the capacitance on a capacitor, well, you may be creating trouble for your circuit. I can't put this one in just yet because I gotta clean some of that glue up. I'll show that in just a minute here. That's where the nasty capacitor was, or the old one, where it's got all the nasty glue. This glue is kind of brittle. Sometimes you'll find glues that are kind of like, soft still, a little bit malleable. This one's pretty tough, so one thing I'm noticing works okay right now is if I just kind of take some pliers and just kind of pinch the stuff. That is helping to remove a bulk of it. So we're going to go easily with that for just a minute, get the big stuff off. And then the next thing you want to do is try acetone or rubbing alcohol. So all I'm doing for that is I'm taking some Q-tips. I'll open up my acetone. I'll just kind of dunk this in there until I can get it nice and wet with acetone. Then I'll just go to town on the glue, and it should slowly dissolve with the help of the acetone. And you can see this Q-tip is starting to turn like a yellow color. That's the glue dissolving in the acetone. The acetone did quite a nice job actually. I'll zoom back in on there. As you can see, it's all gone basically. None of it's there anymore. So that means we can take our new component, load it in there, bend our leads like we talked about. I'll go ahead and solder these two just so I can show you how that's done. Now I'm not a professional solderer or certified or any of that stuff, but here's what you do. You take your soldering iron, grab yourself a nice little piece of solder right here. Get your soldering iron, make sure you're in a well ventilated space. My iron tip is heated up. I'm using a 700-degree Fahrenheit tip. If you have a station, you'd set it to 700 degrees Fahrenheit. So we'll just kind of touch this a little bit, tin it, right? Get a little bit of solder on there. Now we'll heat up this joint for like 2 seconds, and then we'll start applying some solder. And this is flux core solder, so you can see the flux kind of allowed it to kind of ball up real nice around that component lead and get a really nice looking solder joint there. So let's move on to the next one. We're already tinned, so go there for like 2 seconds, and then start adding solder to the tip. And make sure it wants to run onto the actual solder joint pad, this PCB pad right there. Okay, now we'll do this one. See if I can bend my lead this way a little bit just to kind of show. There's another one. You saw the solder kind of ball up real nicely on here and fully fill out that pad. Now here's the pad that we damaged slightly, but I don't think it's going to be too big of an issue soldering this one, so let's go. There it was, it flowed real nice. And there you go. Clean off your tip in your tip cleaner, and you're done. Well, not quite. You still have to trim your leads. So next thing you do, you bend these up, like so. And then you take these guys here. I have these in my tools video. If you want to buy yourself a pair, they're really nice for this because they got like the angled tip there. And just come in. I'll do it left-handed for you. Then just come in and snap off each of these leads nice and close to the circuit board. There's that. And there's that. So that's how you replace capacitors. And then you can come back to the other side and kind of straighten them out just so it looks nicer. I'm going to go ahead and replace the rest of these off camera, and I'll come back when it's time for the transistors, because there's something to talk about with those. So here we are with all the new components installed. I realized I didn't talk about really what I replaced these with, per se. I know we touched on these guys, these 330s. I replaced it with an Nichicon PW because it looks like it's related to power, and I upgraded it to a 50 volt because it's what I had. And when you upgrade the voltage on a capacitor, it doesn't hurt anything. Let's move on to some of these guys in here. These were 100 microfarad 6.3 volt capacitors, as you can see right here. I upgraded these to 100 microfarad 25 volt because, again, look at the size of these things. Like the 25 volt Nichicon PW series capacitor, it's gonna fit anywhere a 6.3 volt would on an older receiver. So I buy 100 microfarad capacitors in 25 and 50 volt, so that works well for me. Same thing with the 33 microfarad. That one was a 10 volt, and as you can see, it's the same size. This is a 50 volt. I have these in 50 volt, that's just how I do it. Now these film guys, these are WIMA MKS film capacitors, and they do not have a polarity, which is awesome. So I just put them in however I want, and I arranged them so they're all like, you know, got the text the same way, so it looks kind of cool. So now what we get to do is move on to this guy and this guy. These are your transistors. Transistors are semiconductors. What does that mean? It means magic. They have 3 pins, and you can see on the board. There's like a little diagram kind of showing what each of those 3 pins is. That's the emitter, the collector, and the base. So I have this little diagram on the back here, and where I have the transistor diagram. The base is always going to have this flat line here. The collector is always going to be the line without the arrow, and the E is always going to be the line with either an arrow going this way or an arrow going that way. And the difference between those arrows is NPN or PNP. The reason I'm talking about this is we can't put our new transistor in the same way this one is. So like you can see, we've got like this little half circle thing on here, and we'd think that we could put our new one in the same way as the old one, kind of like we do with the capacitors, positive to minus, but we cannot because Pioneer used transistors with a different pinout compared to what we have in the modern day, like this KSC 1845. The KSC 1845 has the emitter on this left side pin, collector's in the middle, and base is on the right side. If we look here, and we look at the little line on the board, we see that the right side pin on that transistor is the base, because it's got that flat line on it. So that already tells us that if the right side line on here is the emitter, we can't put this in like this. So what we're going to have to do is flip it so it's not the way it went. So it's not the way the original one goes in. I will replace these now and make sure that we have the correct pinout. So we've got our new one in right now. It's not like the old one was. Remember, the old one had the flat face kind of facing the front of the receiver. This one has the flat face facing the back. And I pulled that collector pin out so it could go to the collector thing on the board. The remaining transistor is right there. The marking on the board is the same for each transistor, but they're oriented differently, and that's because of the different emitter, base, and collector pins. So I'm going to remove that one, put in the second KSC 1845, and we'll be good to go. Okay, so now that everything that we want to replace has been replaced, we can put this board back where we found it. And we're just going to kind of pull a little bit, get these shafts over the sheet metal here, feed them back through, and won't worry about the wire ways just yet, because what we need to do is check to make sure we've done this correctly. So what we're about to do is we're about to test the receiver and make sure it still works, because I know it worked before I started this. And if it doesn't work now, I know exactly where the issue is. And that would be the preamplifier. So I'll just put in 2 because that's enough to hold it in place and make sure we don't get a shock or anything. We'll hook this up to the dim bulb tester just to be safe. Okay, so I'll turn this on.
kidding. I'll turn this on. I'll make sure nothing is exploding. I'll make sure the bulb on the dim bulb is not bright. Can you see it? There. It's not lit, so that's good. So far it looks like everything is okay. So if a polarity on a capacitor was wrong, we would be seeing smoke by now. So we see that there is no smoke, and since there is no smoke, we can go back here and try hooking up some speakers. So I've got speakers hooked up. Turn the volume down. I'll set this to FM, and we get sound.
Life.org and click the prayer button at the top of the page. The Family Life team will take time to
Definitely be sure to click the prayer button. Okay, so sounds good, it sounds clear. If there were a big issue, it would sound distorted or weird. It would not sound good like that. So we know that the preamplifier now has been successfully restored. So what that means is we can move on to the next board. That's going to be the Phono preamplifier. So I've already unplugged it and disconnected speakers. Before we move on to the Phono preamp, let's clean these controls. You're going to want two things. You're going to want D5 and you're going to want F5. Use F5 on potentiometers because they use carbon more than likely. I think I can even see the carbon inside. And then we're going to use D5 on the switches because they use metal on metal for switching. That goes for the selector switch as well. I have a video on this already, but I might as well just do it again because it's really easy and I don't need you jumping through videos like that because that's inconvenient. So this is the selector switch. You can see it uses metal on metal contacts for the switching and stuff, so that means you use deoxide D5. So all you're going to do is take a little bit of this stuff, you can look at the switch, you can see where the little wipers are connected to the circuit board. You're going to want to get D5 on that stuff, so do a little tiny squirt. And you see there's two wafers, if you will, so you want to get some on each wafer. And just do this a bunch. And you've got yourself a clean control. So that's your selector switch. Now let's move on to the volume pot. The volume knobs are nice because they have nice big openings so you can get your straw in there. You're going to use F5 on here because I see a carbon track potentiometer. So I'll just go right in there. I'll do a little squirt. That's on the one gang, and then there's a second gang back there. Give it another squirt. And then just do this a little bit. That's going to clean her up real nice. It helps to take one of your knobs that you've got off to the side, and then just kind of use that to help your fingers. Like I know Rant's selector switches are really tough to move without a knob, so just do that. That's probably going to be good. Okay, let's move on to these push button switches. For these, you're going to use D5. You can see they've got little tiny holes right here, and I think that's kind of where some of the D5 solvent will get inside. So I'm going to put it down so I can do that properly. I'll try one of them. You can kind of see already, I don't know if you can see that, but it's like squirting the stuff out. There's little bits of it coming out there, so we know it got inside and we know it's cleaning the switch. And then the rest of the potentiometers, I'm going to hit them with the F5, and that'll be that. So you saw me play with one of these in my SX737 video where we had big loud pops coming out of the speakers in Phono. That was because one of these transistors was bad on that board. We replaced all of them and the issue went away. Wasn't able to pinpoint which one it was, but you know what, it doesn't matter because it's fixed and these parts are like 25 cents or less. So what you do to get this thing out is you're going to use pliers, and you see these little plastic standoff guys that it's on in the four corners. You're going to kind of pinch each one. I don't know if you can see that, but right there, you can pinch it and get it so it's like smaller, and it'll create a smaller pathway for your board to kind of walk through. And you got your finger from behind, you can kind of pull. So I got one there. There's two. And these are going to be a little difficult because it's pretty tight back there. There's the third. And this fourth one's going to be a sucker. Okay, I got it. So there we are. Now we have full access to the foil side of this board. So, let's talk about this board. We see we've got capacitors, transistors, resistors, pretty simple board. We're going to be replacing the electrolytic capacitors, the transistors, and these blue guys, these are called tantalum capacitors. These were used in the audio signal path circuits on a lot of 70s stuff, and they're just bad news. Anytime you see one of these tantalums, you want to replace it. You can also assume it's in the audio signal path, so you can probably replace it with an audio grade capacitor. So, we have 4 of those. We have 4 little tiny electrolytics right here, and then 2 big electrolytics. We'll have to look at the service manual to see if these gray ones are audio grade, but they're probably not. And then these yellow ones, definitely not audio grade. They provide filtering from the power supply into this board so it can run. And then we have C1312 transistors, which are NPN transistors. So that means we can replace those with KSC 1845s. But we'll walk through the service manual real quick, confirm everything, and see if it shows us anything important. Okay, it's service manual fun time. So I want to know where the signal enters the Phono preamp board. So this is the full schematic diagram for the entire unit, and I see over here that the EQ amp assembly, or Phono preamp, is right here. I also see your Phono input, the RCA jacks in the back of the receiver, they're right here. And then I see that the signals jump into the amplifier at pins 2 and 8. So let's get out of this. Let's go back down to our board level breakouts here. And here is our EQ amp assembly. So we see pins 2 and 8 is where the signal enters. So we've got the so this right here, this 3.310 on the top and bottom, that's going to be one of those tantalum caps, or 2 of those tantalum caps rather. So we'll want to replace those with an audio grade capacitor or a film. And then over here we've got C14. This is where C1314. This is where your signal is exiting at pins 4 and 6. So that's also going to be audio grade. But we were wondering about those little gray ones in there. What do those guys do, or what should they be replaced with? So first of all, let's look at C5 and 6. Those are your 100 microfarad 35 volt. We see 100 microfarad 35 volt. We also see that they go straight to ground, which is pins 3 and 7. And I know that because the black line means ground, generally, on this stuff. So now we're looking at this 0.4750 volt. That's going to ground, so we could replace that with a PW series. So you got those 4 right here. And then the last ones we're looking at are these guys, C12 and 11. Those appear to be for power because the negative lead goes to ground. So basically the rule of thumb is if a negative lead goes straight to ground, then it's probably a power grade capacitor you're going to want to put in there. But if it doesn't, kind of like C2 right here, go straight into a transistor, well, it's probably got something to do with the signal path. And if that one's going straight out of the board, definitely part of the signal path. So I'll go pull some replacements and tell you about how I chose them. Okay, so I've got all my parts. I never showed you, but here's the foil view. That's what you'd look at if you wanted to find specific component names, since they don't print them on the board. But we can look at our bill of materials here and look at our electrolytic capacitors. This is something very nice that you don't see very often. They actually wrote tantalum on the service manual, so you don't always see that. That's kind of cool. But anyways, our first capacitors, C1 and C2, we're going to be replacing with these film guys right here. Little Wima films, 3.3 microfarad, just like the ones on there, 3.3. Next we've got these electrolytic 0.47s. This one actually did not have a low ESR or Nichicon PW 0.47, so I'm actually going to replace them with films because that's what I've got on hand in that capacitance, and that's kind of how that's going to happen. You can use different kinds of capacitors and different kinds of circuits. It'll work. I don't know how big or important the benefit really is of using the proper type of capacitor. Maybe somebody in the comments can say so if they say something if they want to, but as far as I'm concerned, it will work if that's all you care about at the end of this. It'll probably sound just fine. Moving on to C5 and C6, those big old 100s, those are the yellow ones right there. I've got Nichicon PW 100 microfarad 50 volt, the 22s, those are those gray ones up there that we were looking at. And we've got some 22 microfarad 35 volt guys here. And then last but not least, the very end, tantalum ones, 0.47. Got some nice 0.47s right here for those final signal path capacitors. And then for the transistors, that's listed kind of further down. It'll say Q, and see all the transistors are the same. So we will just replace those all with KSC 1845, and I've got two pairs right here for the different channels. So I won't show myself soldering this, I'm just going to do it and show you the end result. Since I already showed soldering, I'll report back when I'm done. Okay, Phono board rebuild is complete. We've got our nice new films, nice new lytics, and new transistors too. A lot of the parts are right here. Some of these are from the preamplifier rebuild too. But I'll show you how to put this back in now. Getting this thing back in is kind of nice. You just kind of take it and line it back up on those little plastic pin things. And then you just push it in. Make sure all four corners have bottomed out. And then you're done. There's your rebuilt Phono preamplifier. The next place we're going to go is the power amplifier board. That's this thing right here. The way we want to go about that is replace capacitors and transistors. But not all the transistors. So you can see in there, we've got plenty of electrolytic capacitors. 1, 2, 3, 4, 5, 6, 7 that still need to be replaced. There were 2 right there, but I got those in the previous video. I also got these those 6 transistors in the other video as well. We're going to leave the outputs alone because the output transistors are fine, they're working, and they're not necessarily known to fail. So I will just leave those be for now. So here's your output transistors right here, and these use a thermal compound to get their heat energy onto this heat sink. And that thermal compound dries up and loses its thermal conductivity, so you can take some of this stuff, this Dow 340, and redo that. I'll do that in a minute here, but first I'm going to take the time to recap this board, and after that I'll come back, because this is basically the same thing we did with the other 2 boards. I'm just going to look at the capacitors, replace them, see if any of them are signal path, do all that fun stuff, and yeah, I'll talk to you when I'm done. Okay, so the board is all recapped now. We've got all new electrolytic capacitors in there, and we already replaced a few of those transistors. There's actually 4 transistors left that are original that are actually on the board. I decided to leave those because, well, one, I don't really feel like dealing with it right now. But if I did want to deal with it, there are replacements that people say work, the KSA 1220 and the KSC 2690. But I have not seen a driver transistor fail on one of these boards before. I've seen the bias transistors fail and the differential pairs fail, and that's always really bad when that happens. But the drivers, not so much. So I'm just going to leave them be.
It's also kind of hard to get the replacement in there because the leads are much thicker than the ones on here, so call me lazy, but you know, it's just the decision I'm going to make today because that's how I feel. So, we're going to move on to these output transistors. So as you see, I don't have great lighting on this, but there's like a little plastic insulator pad behind each one. And what that is, you call that a mica insulator. And basically what it does is it insulates this heatsink from this heatsink, because this thing right here is electrically hot, this top metal part of the transistor, and you do not want it shorting on this heatsink. So what they do is, well, you've got your insulator there, then on the back you've got like a little plastic piece that it threads into so you don't short with the mounting screw. So but what we want to do is replace the thermal compound on these things so that we can get better heat transfer when it's you know, playing music real loud. So obviously you gotta get a screwdriver in there. So if you have one of these little guys here, there's actually enough room to kind of go in like this, and you can get, and these are your little thermal temperature sensing diodes too, you'll need to undo those. You can get in there and undo these screws and not strip stuff too bad. See, I've got that one there. If you don't have a screwdriver like this, you can take a like a Phillips head bit and then start going in here with your fingers. If they're loose enough, you can try this, which, you know, I loosened it with the screwdriver earlier, but if they're not, what you can do is grab a 1/4 inch wrench. It's going to be difficult to do with one hand, but you can basically go in like this, because, you know, it's a 1/4 inch drive, and then you know, line up the threads and get it out that way, kind of using the back of this with your thumb to apply some pressure so you don't strip it. This is unique to this particular model. Other models don't quite have this setup. I'm just showing it because, you know, this is a very thorough video. Might as well keep being thorough. And then I see 2 screws back here, so I'm going to get all this apart, and hopefully this heatsink will come out, and then we can get some new thermal compound on. We got that out. You can see this board a lot more easily now. So some of your insulators, they'll want to stay on. Others might want to stay inside the receiver, like this one. These are important, and we're going to make sure we clean them and not break them before we reapply here. So this is also a good opportunity to kind of take this and clean it out. You can run it through the sink or whatever. Make sure it's dry. I'll show you how to do the thermal compound right now. Okay, the first thing we're going to do is carefully peel these off of the heatsink, but don't peel them per se. Kind of try to slide them off because we don't want them bending at all. So now what we can do is take our paper towel, and we're just going to wipe the old thermal compound off of each one. So you heard me kind of break it. You hear that little crack. Visually doesn't look too bad to me. I'll probably just send it, but you know, just be careful. Like, you really don't want to bend these, and they're very fragile. So I've got those wiped. Next we're going to go into the actual receiver, and on the backs of these transistors is old thermal compound. So we need to just go in there with our paper towel again and just wipe that old stuff off. And then off camera, I already wiped this stuff down, so we're good there. Okay, next thing we do is we take the paper towel we're using. I was using the inside part to wipe off old stuff, but now we have a clean outside part. We're going to take some Dow 340 and just give her a little squirt right there. That'll be plenty for what we need to do. And then take a Q-tip, kind of mix it in because this stuff likes to become kind of oily and separated. So let's just make sure we've got a good amount of stuff here. So next, what we're going to do is we're going to take this, we're going to paint the smallest amount on the back of each transistor. A little bit of this stuff goes a very, very long way, so we're just putting on a little tiny bit. We're making sure we have full coverage of that entire metal heatsink area. Okay, so that's taken care of there.
Now what I'm going to do, I'm actually going to take our insulators and I'm going to apply them to the transistor itself. And the way I'm going to do that is I'll take one of these screws, right? Notice that these insulators have a hole right here for where the screw actually goes through. We're just going to take that and make sure we're aligned on the transistor using the screw. Make sure we're vertical. And we'll just kind of put these on here. Pinch them onto the transistor so they stick, and they will. You also don't need this screw, you can just kind of eyeball it. It's pretty easy to tell that you're on. Okay, and now that we've got those attached, we will again take a very thin layer of the Dow 340 and we'll paint the other side of the insulator. So the insulator wants to kind of move around as I do this. I'm just kind of dabbing it, if you will. Not like the popular culture gesture, but you know. So what I just did there is I kind of gave the back of that insulator enough thermal compound so when it comes into contact with our heatsink, we're going to be okay. So now I'm going to carefully, one-handedly set this back in here. Now there's some holes here that stuff's going to want to go through. So be careful there. So it looks like we're in. And now we can send our screws back in after we reposition this one because it got messed up from me putting the stuff in. That won't be too bad to fix. Looking pretty good there. Got those tightened carefully. I put the tiniest dab of thermal compound behind the temperature sensing diodes here. They don't do that from the factory, but I figure, you know, why the heck not? I don't see anything wrong with doing that. I wiped this out. Still got to put 2 more screws back in, but then we can throw this on the dim bulb and see if it still works. Turned on, no speakers attached, no bright bulb. That's a good sign. Smoke up there. I haven't turned it on since I checked the Phono preamp. I don't see any smoke. Take monitors on.
Visual sections for those Russian leaders immediately.
I had never.
Sounds fine to me. So, we will move on to... what do we do next? Let's move on to the filter capacitors. So, for the filter capacitors, here they are from the bottom. They have a little resistor on them. That's to kind of help dissipate the voltage when the thing is turned off. I'm not sure if there's any other function aside from that. It's also not completely necessary. So since it's there, I'll consider putting that back in when I get the new stuff in, but if it's painful in any way, I'm just going to leave it out because it's not fully necessary for the thing. So what you're going to want to do here is make sure you take a picture of these because you're going to want to remember which one's positive and which one's negative. These are the 2 capacitors you really don't want to screw up the polarity on. So that black one right there where it's got the little black point on the lead, that means it's the negative. And if it's silver, that's the positive. One filter capacitor is going to have a negative going to ground, and the other is going to have a positive going to ground. What is going to ground? Well, it's these black wires going to this ground block down here. That's how a DC coupled power amplifier works. Is it's got 2 filter capacitors, one for a positive DC leg and one for a negative DC leg. What we're going to do is we're going to cut these wires as close as we can to the original leads, and then we're going to remove the filter capacitors from up top. Okay, so I feel pretty good about these filter caps since they have the resistor on them, but we need to be sure that we're safe, and we need to check these for voltage so we don't get a nasty shock if we happen to touch our fingers to each lead. And as you can see, the resistor is definitely doing its job. We've got like nothing on these caps. They're completely discharged, which is excellent. It's exactly what we want. And that means it's safe for us to start removing them.
Okay, so this one I've already removed. You know, I cut it as close as I could to there as possible. We're going to keep going here. We're going to make sure we use the back side of this. We'll get 1 wire, 2 wire, and 3 wire. I'll leave the resistor on for now. I'll get that later. Okay, so you can see the originals. They are 35 volt 4700 microfarad. I'm replacing these with 6800 microfarad 50 volt. And I'm doing that because this is the same diameter, which means this bracket is going to fit right on here, and we're going to have a real nice fit for this new filter capacitor. I up the voltage because, you know, these see some of the highest currents in the entire receiver, so having a higher voltage capacitor means it's going to be even better suited for what it sees. Not that these aren't, this is just going to be even better. And then I upgraded the capacitance value because sometimes it helps to give the amplifier a little bit more headroom. Some amplifiers that's true. This one probably wasn't necessary because it's not a very powerful or complicated amplifier to begin with. And then when you do this, when you upgrade the capacitance on a filter capacitor, you run the risk of frying your transformer, because what happens is when you first turn your receiver on, these guys want to charge up, and 6800 microfarads is a larger number than 4700. So these will pull more current at startup versus this thing. So you got to make sure your transformer can handle that when it happens. It's probably going to be fine. I've done it with these guys before, but just something to keep in mind. Like, you don't want to put like a 10,000 microfarad capacitor in here. It's just overkill and ridiculous. So now I want to address a very important question some of you may have. How the heck do you expect to get 3 wires on this little tiny thing right here? Well, you don't. You see, the capacitors from the factory, they had these nice little posts on here, so you could wrap the wires around them and get 3 on there and then go and solder. But these, I couldn't find a capacitor with that on it for this receiver. So what you do, and why these little ring terminals are here, is you take one of these guys, you just put it on there, and then you take a pair of pliers, a crimp tool really, but I don't have a crimp tool, and you just pinch it on here, kind of create a nasty homemade crimp, if you will. What you're trying to do is get like a little bit of mechanical grip on there. You don't want to not have that, and I'll explain why in a minute. So I'm just going to pinch this one here, get my little awful crimp. So there, it holds the weight of the capacitor. And make sure you got these such that they're kind of faced away from each other. Like, for example, you could have this such that the ring terminals are kind of like this, really close to one another. You don't want that, because that's going to introduce more potential for arcing. Not that this is a high enough voltage machine to see arcing, but you just want these as far apart as possible. And then you'll take your soldering iron, you'll heat this up real nice, and solder the terminal onto the lead for the capacitor. So what I'm going to do is I'm just going to heat it up kind of right there, and then we'll just add solder, and we'll see it kind of fill up that cavity. And we'll take it off, and boom, you got yourself 2 very, very solid connection points right there. So after that, what it becomes is stripping each one of these wires back a little bit, and then kind of wrapping it through the terminal, and then you just solder them all. So sometimes with these, Pioneer wasn't too generous with wire length. Maybe you need a little bit more length on, say, this wire. I see something that can be done to achieve that right here, and this can happen in other places in the receiver. So, you know, like I need a longer wire. What do? Well, I can pull this back and I can see that it attaches right there. Well, what if I remove this from the wire way, like so, and then I pull down? Look at that. I got like an extra inch of length right there, so now I can actually attach it to my filter capacitor much more easily. So that's how you would go about that. I'm not going to show myself soldering these wires back in. It's pretty simple. You just, you know, pull off some insulation with your wire strippers, wrap the wire around the terminal, and then solder it. That's basically what you do. So real quick, here's how I've got it set up here. I stripped each wire, cut it pretty short, and then just kind of fed it through and bent the leads with my needle nose pliers here. Got them nice and on the terminals. Didn't have too much trouble with lead length. I had to rotate this capacitor a little bit to get enough length to get this wire on there without having too much tension. And that red one that I was concerned about earlier, I think I'm going to be able to just put it right back in the wire way because there was enough wire. So I will get these soldered up and show you what that looks like when it's done. Alright, got it done. It's really nice doing this on Pioneer because they used a solid conductor wire, which means it's not like a bunch of copper strands, it's just one solid piece of conductor underneath that insulation. I tried to fill in the ring terminals the best I could with solder. You gotta be careful with how you apply the heat here because you can end up just kind of having it all melt to the base if you're not careful. But I think I did a pretty okay job. Pretty happy with how it looks. Then when you're done, just give her the nice little tug test. Make sure you don't see any of the wires moving inside of your solder joint, because that would mean you have not successfully soldered your wire to your capacitor. So now that we're done there, we get to move on to the board beyond this thing, which is the power supply. So the power supply board is the one that is back here. We got a bunch of big old capacitors on here, a bunch of fuses, and a bridge rectifier situation back there, 4 diodes. The first thing I'm going to do on this thing is replace all the electrolytic capacitors. I'll test it out, and then I'll move on to some transistor and diode replacements. The way you get the power supply board free from the unit is just like the Phono preamplifier. You just take your pliers and pinch the little plastic thingies. Just kind of let them slide up. You're going to notice something very quickly with this board though, and that is that it doesn't really want you to get underneath it. So there's a few things we can do to remedy that. We'll have to come over here for me to show you. The wires for the power supply board kind of come through these holes in the chassis right there and there. So as we're trying to bring this up, we see that we're kind of yanking on some wires here. A lot of them are in this wire way, so we're going to clear everything out of this wire way. Okay, so you can see right there I've removed everything, so now I can actually move this thing. And this is great and all, but you know, we're still a little bit tight. There's still 1 or 2 wires that are really limiting us in how much we can move here. One of them I see in particular is this red wire right here. So what I'm going to do is I'm going to follow this red wire. I'm going to see that this red wire actually goes straight to the power amplifier board. So I could remove the wire at the power supply board, but it's going to be really hard to reattach it. So what I'll do here is I'll remove it at the power amplifier board, because look how open this is. We're going to have a much easier time stripping and reattaching this wire to the amplifier board. So I'm just going to get my finger on it and I'm going to untwist it until it breaks. Right? Okay, so there it broke. So now if I pull from behind here, you see that wire move? That's because we just gained all that extra length. And now we can actually get a soldering iron underneath this thing, and it's going to be, you know, not terrible. So next thing we got to do is replace all of the capacitors on here. The way we're going to do that is, well, one, we can just look at them and replace them as we see them, or we can open up the service manual, look at the list of them, pull them, and install them. So I will just do them one by one since I've got a lot on hand. You can go by the service manual if you want, if you're trying to order parts, or just, you know, double check each one of them. And you can read most of the values from here. But yeah. So I'm going to remove these, install new ones. These are all going to be Nichicon PW. They'll all be the same capacitance value. I'll probably step up the voltage for the same reasons I mentioned earlier. And I'll report back when I'm done, and then we'll test this thing and make sure it still works. So I'm working through the power supply board here, and I'm replacing the transistors because these transistors see quite a bit of heat, and heat is the number one enemy of semiconductors. So anything that gets hot regularly should probably be replaced in here. This is a perfect example of one. This TO220D 313D. It says 6 amp on there. That's pretty good because that tells us we need to have at least a 6 amp capable TO220. The MJE 15030G is a perfect choice because it is an 8 amp transistor. So this is going to be even stronger than what we already have here. Now I'm showing you this because what we need to do, first of all, this was screwed to the circuit board, and it was a total pain to get out because it's in the very bottom corner where you can't really reach. You gotta take this off of the heatsink, obviously, and put the heatsink on your new transistor. So that's pretty easy. And this way you're not worried about a mica insulator, which is kind of nice. So I'm just wiping the old stuff off. I've got my Q-tip from the last time. I will put some thermal compound on my new transistor back here like so. A little goes a long way. Cover the entire area of the back face here. Not bad, not bad. And then we'll put it on heatsink. Okay, I kind of missed it. So I can clean that up later if I want, but I don't think I will. And then we just get our screw in there. And then to tighten it, we'll just put our finger kind of right here because it's going to want to twist it like this, you know. You want this to be totally perpendicular. You want these leads to be totally perpendicular to this bottom face here so it goes into the board straight. And you want a good solid connection here. So that should be pretty good for us. Well, let me straighten it. Okay. That should be okay. And then we'll notice that on the board we're going to want to pull the middle pin out a little bit so we can actually get it in. And that way I can actually insert it into the board and then we can solder. We're going to want to refasten the heatsink before we solder the thing back on, because say you soldered it first, then you go to tighten it, well, guess what? You're probably going to put unnecessary stress on those solder joints, and it'll cause you trouble down the road, and you don't want that. That's why we're here, folks. We're here so we have no trouble down the road. There it is, folks. Brand new power supply board. Some people recommend you replace the diodes, and I don't see an issue with it. There are better diodes called like ultra fast soft recovery or whatever, something. You'll see people talking about it in the forums. You can go ahead and replace your bridge rectifier diodes with those, and then there's a few other diodes on this board. Yeah, they are hiding behind the capacitor. You can replace them if you want. I don't really feel like it today. I've never seen them fail. People say you can get a little bit better performance out of like a newer part, but today I'm not going to do that. I'm just going to leave these ones here. Besides, these really big ones back here, they've got really thick leads, as you can see, compared to other stuff, and that makes them kind of hard to remove. And when that happens, you end up destroying PCB traces, and not always great. The transistors were replaced. There was one back here, a TO220. I replaced it with a MJE 15030G, just like the one on the heatsink. And then there was a little tiny TO92 right here. It was a 2SC945. I replaced it with a KSC945. So got a nice, reliable, solid power supply and brand new filter capacitors now. Last thing to do, folks, in terms of parts replacement is the tuner board. So, like I've said before, I don't know too much about tuners, and in terms of aligning them, I do not know how to do it. But I will soon, so stay tuned for that. But that's not today. So, in this video, all I'm going to do is replace all the electrolytic capacitors. And I'll use Nichicon PW for basically all of those. And it'll be just fine. So you can look at the electrolytic capacitors in your bill of materials in the service manual, or just go one by one, pull them, look at the value, find the value, and throw a new one in. So I'm going to do that, and I'll report back when I'm done. Alright folks, I jumped the gun here a little bit, but the tuner board has been fully restored. Every single electrolytic capacitor on there has been replaced with either another electrolytic or a film capacitor. So it looks pretty good here. You know what this means, everyone? We're done. Well, we're not done. There's still a few more things we need to do before we can declare this thing taken care of. Unfortunately, we should have done this right after we finished playing around with the power amplifier board, especially if we were to have replaced transistors, because we need to set the bias. And when you play with the power amplifier board, when you change out transistors, etc., it's going to throw off the bias. The bias is basically the current drop between the transistors, I think. It's basically, you know, if it's too high, it's going to blow up. If it's too low, it's not going to sound good. So, what we got to do is we got to go to our service manual here. So here it is, folks. We've got the power amplifier adjustment. Look, it says right there, do this when any of the transistors have been replaced. But it's also a good thing to check in general, especially when these things are this old. So we've got VR2 and VR1. What we need to do is attach our voltmeter at, what does it say, between TP1 and number 1. So basically, if we look at this board, there's going to be some terminal posts on here that we're going to need to measure a drop between. So once we measure that drop, we want it to be around 15 millivolts, 10 minutes after the power switch is turned on. This has been on for like 5 minutes, so just to get a good baseline and make sure that we don't have anything really wrong going here, we want to check it now, because like if it's like running at like 100 or something, that's going to be pretty bad. I bought a new tool, everyone. I bought something I should have bought probably a very long time ago. Little tiny spring clip jumper guys. So we're going to start with the left channel. We're going to connect one of these to TP1 and the other one to pin 1. And then I'll take my probes here. I'll put the red one on red. Doesn't really matter for what we're doing here, but I'll just do it that way. And we don't want to touch our probes together now. Then I'll put the black one on black. And we can see 16 millivolts. And the reason it's in check is because last time I did this when I was replacing transistors, I already did this adjustment. But it's really important that you do this if you have, you know, just played around with this stuff, because this value is very important. So if that's good, we can move to the other side. If you recall, there were some parentheses in that thing. In parentheses was TP2 and pin 7, so I've just moved the jumpers to there, and we've got 15 millivolts, which is just perfect. I'm not going to adjust these any further. I'm just going to leave them as is. So this is running exactly as it should. This amplifier is so cheap that it does not have a DC offset adjustment. So that's kind of a shame. I wish it did, but it does not. but that doesn't mean we can't check it. And the way you check DC offset is you put one probe on ground. We'll just ground to like right here or something, it doesn't really matter. And we'll do the left channel. We've got -4.3 millivolts. And then over here on the right channel we have, bear with me, another very small DC offset. So we're in excellent shape here. This is a very, very healthy stereo receiver.
If you want to take a
Tuner
look back.
works.
That was a good.
Sounds very good to me. So now I think what we can do is listen to everybody's favorite song, Walk Through the Park by Track Tribe. Alright, are you ready? Sounds very good. Really nice stereo separation. Alright, here's our test setup. We've got a multimeter and a scope. And what's going on here is we have 8 ohm loads attached to the speaker terminals. And we're going to go on the right channel first. We've got the oscilloscope measuring across the right channel resistor and the voltmeter across the same resistor. So what that allows us, since this is not a fancy scope, we need to do this. Fancy scopes will give you the voltage, right? So I've got a frequency generator here on the phone. We got it set to a 1 kilohertz sine wave. So now we just kind of bring it up here. And we got to turn down our volts per division. And we see we start clipping right around there. So what is that voltage? If we kind of pull back until we don't see that anymore, that's about 13.47 volts, which is pretty good, I think. So now what I'll do is I'll go to an Ohm's law calculator. So we've got 13.47 volts into 8 ohms. That is 22 watts. So I believe this is rated at 20 watts per channel. So we're coming in just a little bit above spec. So that's pretty good. Now let's switch to the other channel. Okay, so now we're on the left channel. Let's bring this up and see if we get the same number. We get 21.3 watts. So still within spec. One kind of fun thing if you were curious, right now we've got Walk Through the Park playing through this scope here, and I'll just turn up the volume a little bit. You can kind of see that it's Walk Through the Park, boom, 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 boom. You can see the tempo of the music in there. When I turn this up high, and you see those flat lines up there, like I got this at a very high volume, that's clipping. That is basically the amplifier reaching its limit on what it's able to do for the music. So if I turn this down a little bit, and I increase our volts per division, you'll see that we've got, good music right there. That's going to sound good to us when we've got it through the speaker. But when we turn it up, take the volt per division down and see, you can see some of those flat lines showing up on there. That's the amplifier clipping. That's us reaching the limit of what it's able to do. Fun visual representation of what the amplifier is doing if you've never seen that before. So at this point it's really just putting the faceplate back on, listening to it for a little bit, making sure everything's okay. I'm sure it's going to be okay. We just put it through hell basically with those tests. And yeah, that's how you restore X3X Pioneer, at least an SX535. Like I said, bigger model Pioneers are going to be similar to this, but quite a bit different. A lot more components, a lot more to them, more adjustments, all that good stuff. So this video, I really want this to serve just as a if you were curious to see what the heck goes into this, this is what goes into it, and now you know. You can use this to either do it yourself or decide, I'll try to find somebody to do that for me. But finding people to restore stuff is difficult, and you know why it's difficult?
Well, you just saw how long this took. This took me basically all day, and I'm fairly experienced, so I can get through these fairly quickly. And this was a low model amplifier, so I got it through. So I got through it in a day, but it takes a lot mentally. You've got to have all the right parts, and you know, if you're gonna be, let's say you're a mechanic and you've got an 8-hour job, and you charge $100 an hour, just standard labor rate. That's $800. No one's about to pay somebody $800 to restore a Pioneer SX535. So another amplifier that's even bigger, like a Marantz 2270 or a Pioneer SX1280, you know, you might find somebody to pay $800 for that, but guess what? You just got that many more hours of labor, so it gets into the thousands if you're going to use that rate of $100 per hour. I've done this in the past and restored receivers for people, and you know, at the end of the day, it comes down to, like, after parts costs, I'm making like $5 an hour doing this for somebody, you know? That's just not worth my time anymore. When I was in college trying to, you know, get by and make more money, this was an okay way to do it, because, you know, any money's good money then, but now as an adult with a full-time job and family, you know, I value my time maybe a little bit more than I did when I was, you know, 22 years old at the end of college. So that's why it's hard to find somebody to do this stuff. It's just not, it's not cost effective. And that's why there's not shops that do it either, because they can't make their money back with the amount of labor it takes to do this.
And there it is, folks. A fully restored Pioneer SX535. Look at all that junk we pulled out of there. All of these things posed a risk, if you will, or, you know, they just could have gone bad. Now that they're not inside of this receiver, they can't go bad. They've been replaced with things that won't go bad. Especially these guys here, these transistors. The transistors on these Pioneers are known to be very problematic, and it's good to replace them. And when I say that, I'll specify, I mean in the early power amplifier stages, the preamplifier stages, and the phono preamplifier stages. That's where you want to be really worried. So, anyways, I got the faceplate back on, everything is working great. Just listening to the radio, sounds fine. And great stuff here. Really happy with how this one turned out. Not pictured here is the replacement lamps. You know, we upgraded to LEDs in here, and I do not have the old lamps because, well, they were thrown away a long time ago. But here it is, folks. That's how you do it.
So with that, thank you so much for watching. This is probably the last really long video I'm going to make for a little while. I don't really know what the Jaguar has in store. There might be some long ones there, but the 2230 that you've all seen, I'm going to take that kind of board by board and make individual videos on each board so I can focus really well on that. Because I know that the 2230 is one of the most popular Marantz receivers out there. A lot of people are going to want to see it in great detail, so I will do that for all of you. Thank you to all the subscribers, and if this helped you a lot, please consider the super thanks button. Okay, I'll see you in the next one.